Okay, so now we'll try solving this problem of an 8-point DFT for x of n 1, 2, 3, 4, 5, 6, 7, 8 using this DIT FFT. So we'll do the basic steps first and then we'll get into the diagrammatic solving. So the sequence given to you is x of n 1, 2, 3, 4, 5, 6, 7, 8 and it is mentioned 8-point DFT. So basically your n will be equal to 8. From which we can understand that m will be equal to 3 because 2 raised to m should be n. So correlating n and m, we find out m is equal to 3. So there will be 3 stages and that this will be the total number of inputs. Now we have to discuss about what is to be discussed, the order of the stages. Now there will be 3 stages. So if we are considering the 3 stages, the last will be n point. So n is 8, so it will be 8 point. Before that it will be n by 2, so this will be 4 point. And before that it will be 2 point. So these are the 3 stages. Now 8 point will be done 1 time, 2 raised to 0. This will be done 2 times, which will be 2 raised to 1. And this will be done 4 times, which will be 2 raised to 2. The logic of the butterfly diagram should be clear. It will be, if we have 2 signals A and B over here, we have the twiddle factor W and K and minus 1 factor here. So this will be A plus B W and K and this will be A minus B W and K. Now what would happen is we need to determine the sequence, the twiddle factors for each stage. So the twiddle factors required for each stage would be for 8 point, it would be like Wn02 Wn n by 2 minus 1. So we can see that it will be W802 W8, 8 by 2 is 4, 4 minus 1 is 3. So the twiddle factors required here is from W80, W81, W82 and W83. So we need to find out these many twiddle factors, which is a important part of this particular thing. Now if we find, there is a reason why I found out these twiddle factors, because if we find out these 4, we can automatically find out the twiddle factors required for the other stages. Now what would be the twiddle factors required for 4-point DFT? For 4-point DFT you will be needing W40 and W41, which we have already seen. So if we get W80 and we need for 2 DFT, we need W20. So ideally you know that this term will become equal to 1. And if we are finding out these 2 terms, W82 is correlated with W41. I'll just explain how it is. W82 is basically e raised to minus j 2 pi into 2 by 8. Now if we cancel this, this becomes 1 by 4. So that becomes 2 W1 4. So I hope you have got this point. So W82 can be treated as equivalent to W41. So that is why I said if we find these 4 factors first, then the finding these two, the remaining factors would be an easy task. So let's find out the twiddle factors. So we have to find out the twiddle factor W81. So as we look over here, W81 will be equal to e raised to minus j 2 pi into 1 by 8, which will be equal to e raised to minus j pi by 4. And this will result in cos pi by 4 minus I sin pi by 4 equal to 0.707 minus 0.707i. Remember, this is a complex number. Similarly, W3883 will be e raised to minus j 3 pi by 4. The 2 and 8 will get cancelled, so it becomes 3 pi by 4. This becomes cos 3 pi by 4 minus I sin 3 pi by 4, making it minus 0.707 minus 0.707i. So we have found out the twiddle factors. Now as part of the next operation, we are supposed to write the sequence in the bit reversed order. So when we speak about bit reversed order, we need to consider our inputs as follows. So if we are to represent the signals using the particular positions, we can write it as x of 0, x of 1, x of 2, x of 3, x of 4, x of 5, x of 6, and x of 7, representing the 8 inputs. So this will be 1, this will be 2, 3, 4, 5, 6, 7, and 8. Now as I mentioned before, we are taking the binary of the positions. So the position is 0, 1, 2, 3, 4, 5, 6, and 7. So we write the binary. So 0, 0, 0, 0, 0, 1, 0, 1, 0, 0, 1, 1, 1, 0, 0, 1, 0, 1, 1, 1, 0, 1, 1, 1. So these are the binary values. So when we bit reverse this, it becomes 0, 0, 0, 1, 0, 0, 0, 1, 0. This becomes 1, 1, 0. This becomes 0, 0, 1. This becomes 1, 0, 1. This becomes 0, 0, 1. And this becomes 1, 1, 1. So when we write it down, it becomes x of 0, x of 4, x of 2, x of 6, x of 1, x of 5, x of, this becomes 0, 1, 1, 0, forgive the mistake. The 1, 1, 0, when it reversed, it becomes 0, 1, 1. So this becomes x of 3 and this becomes x of 7. So x of 0 is actually 1, x of 4 is actually 5, x of 2 is actually 3, and x of 6 is 7. X of 2 is 3 and x of 6 is 7, and x of 1 is 2, x of 5 is 6, x of 3 is 4, and x of 7 is 8. So we have found out the sequence in the bit reversed order, and this shall be used in our diagrammatic concept here. Okay, so our particular system will be done here. So it will be 1, 5, 3, 7, 2, 6, 4, and 8. 1, 5, 3, 7, 2, 6, 4, 8. That is a bit reverse sequence. So if you remember, what was the output supposed to come over here? This would be the 2-point DFTs, and it will be happening 4 times. So I'll be connecting these two as a first butterfly, these two as a second butterfly, these two as the third butterfly, and these two as the next butterfly, the fourth butterfly. So it substantiates the fact that 2-point DFT is done 4 times. The twiddle factor for 2-point DFT is W20, and you have a -1 here. W20 -1, W20 -1, and W20 -1. So we have to find out the output of this stage. So since W20 is basically 1, we can by default write the answer here as 1 plus 5, 6. Here it will be 1 minus 5, it will be 4. This will be 3 plus 7, 10. And this will be 3 minus 7 minus 4. This will be 2 plus 6, 8. Then it will be 2 minus 6 minus 4. This will be 4 plus 8, 12, and this will be 4 minus 8 minus 4. So I hope this point is clear and your stage 1 is solved. Now we have to draw the second stage. And what is the second stage? It is a 4-point DFT which happens 2 times. So if you remember what we did in the previous stage of previous question for a 4-point DFT, we combine these two to create one 4-point, and then these two will be combined to create the other 4-point. So the top arm of this butterfly will be connected to the top arm of the other butterfly. And then the bottom arm will be connected with the bottom arm of the other butterfly. So this becomes W40, this becomes minus 1 here comes minus 1, and this becomes W41. Similarly, you combine these two butterflies to get this particular diagram. The upper arms will be connected, and then the lower arms will be connected. This will be W40, and this will be minus 1 here. This will be W40, sorry, this will be W41. This will be W41, and this will be minus 1 here. So I hope you got these particular concepts. So now we have to work out the state's output. So it will be 6 plus 10 basically over here, equal to 16, and this will be 6 minus 10 here, minus 4. Since it's the upper arms being connected. W41 is equal to minus I. So it will be minus 4 plus minus 4 minus I would result in, plus minus 4 minus I will result in minus 4 plus 4I, and this would result in minus 4 minus of minus 4 minus I, so it will be minus 4 minus 4I. And just like that, over this stage it will be 8 plus 12 equal to 20, and this will be 8 minus 12 equal to minus 4. This will be, so this is minus 4 out here, so this will again be minus 4 plus minus 4 minus I, which will be 4 plus 4I, and here it will be minus 4 minus 4I. Okay, so I hope this point is clear, and now we'll have to move on to the last stage. Okay, so we are moving on to the third stage, and when we speak about the third stage, it is basically the 8-point DFT, which will be done one time. And as per our concept, an 8-point DFT is created when we combine the two previous 4-point DFTs. So if you look over here, we have the previous two 4-point DFTs, one over here and the other one over here. So each of these has got the first arm, second arm, third arm, and the fourth arm. And this has got the first, second, third, and the fourth arms. So like what we did here for the connecting bottom arm and the top arm, we'll be connecting the first arms of the two butterflies. So this is the first. So we are connecting the arms with respect to, so we'll be connecting the arms right now. So based on the information we have, we'll be having two 4-point DFT butterflies here with 4 arms each. So we'll be connecting the first arm with the first arm of the butterfly, and then we will be having, we have to complete that butterfly, so we'll be connecting this the other hand too. It's because I'm trying to make it perfect, the diagram. So this one comes about to be the first butterfly. Okay, now we have to draw the next butterfly. So like it is mentioned over there, for W80 or for 8-point DFT, we had mentioned that it requires 4 butterflies or 4 twiddle factors, and this is the reason why you need the 4 twiddle factors, because you'll be having 4 butterflies at the end. So we'll have to draw the other butterfly too. Kindly bear with me. It's because I'm using this particular tool that it's taking a bit time. A hand-drawn diagram would have been much easier, but see the difference in the beauty of the diagram when we draw it in a perfect way. I hope you see the difference in comparison with what I have done with the previous 2 stages. So you can, it's very important that you represent these diagrams using the scale and pencil, not just a hand-drawn diagram, because sometimes it makes a big difference. So I guess you have seen the 4 butterflies here and the last one over here. So like it was mentioned over there, the 4 butterflies, they require the twiddle factors. So the twiddle factors used will be W80, W81, W82 and W83. So these are the twiddle factors to be used, and you require the -1 on all the arms. So I have the -1s placed here, -1 and the -1. So the entire butterfly diagram is going strong over here. So now when you compare this particular thing, your output will be when we combine these 2 butterflies, that is this arm and this. So for maybe for your understanding purpose, I'll highlight it with a red mark. So this arm is going to be combined with this arm. So 16 and 20 will be 36, and then their difference will be -4. Then we have to combine these 2 arms. So I'll be representing it with this red and this red. So what would be the state here? Here we have a certain amount of a problem. Not a problem actually. Only thing is we need to operate and calculate it. So this will be like 4 and -4 plus 4i plus the signal at that arm is -4 plus 4i into what is W81. W81 is 0.707 minus 0.707i. So I have solved this particular equation, -4 plus 4i plus -4 plus 4i into that twiddle factor. Eventually when we solve this thing, we get it as -4 plus 9 point we get the answer as minus 4 plus 9.656 I. 9.656 I. And similarly, when we do this particular operation again for the other arm, it would become minus over here. So we'll just do some minor corrections and we'll be doing this particular operation here. So this is actually a minus sign, and when we perform the minus sign out here, we get it as I hope you're following me. So this will be minus 4 minus 1.656 I. Minus 4 minus 1.656 I is 1.656 I. So the answer comes here minus 4 minus 1.516 I. Sorry, 1.656 I. Minus 1.656 I. And the next what we have to do is we have to solve this butterfly, which I'm highlighting it with the arm 3. We have to solve this, and when we solve it again, we get it as to solve it, what would it be like? We have minus 4, and the twiddle factor is, so let's write down the equation here. It will be minus 4 plus the signal there is minus 4, and the twiddle factor is WA2, and WA2 is minus I. So this will be minus 4 plus 4I. So this will be minus 4 plus 4I, and this will be minus 4 minus 4I. And the last stage we have to do. So over there, the last stage will be connecting these two arms. So 1, 2, 3, 4, and these two arms. So when we look over here, the equation to be solved is minus 4 minus 4I plus, for the first top arm output, it will be minus 4 minus 4I into the twiddle factor is W83, twiddle factor is W83, which is minus 0.707 minus 0.707I. So this will be like minus 4 minus 4I plus, when we open this bracket, it becomes, we have the values over here itself. So only thing is we need to substitute them correctly. So this will be 2.828 plus 2.828I plus 2.828I minus, so this will become plus, these term and this term will become plus, but because of the I square coming up, this will become minus, so this will be 2.828. So we cancel off these two terms, and again we get the, so we get the output as minus 4 minus 4I plus 5.656 I, making it minus 4 plus 1.656 I. So that will be the output on this part, the top arm. minus 4 plus 1.656i. And similarly, when we alter the term and perform the operation, this becomes minus and this becomes minus. So let's see what happens. This becomes, when this becomes minus, we get to see that it's minus over here and this is minus, and this becomes minus, and at this point of time our output will be minus 4 minus 9.656i. So that output is written over here, and we can compare this output. This was already done using an online FFT calculator, and for this sequence 1 2 3 4 5 6 7 8, the output is 36. Minus 4 plus 9.656i, we have got it, minus 4 plus 4i, minus 4 plus 1.656i, minus 4 minus 4 minus 1.656i, minus 4 minus 4i, and minus 4 minus 9.656i. So we have got the output in the correct order, so we can write the output that we have obtained in this form of a direct in the normal order y of n. We can write it as 36 minus 4 plus 9.656i, etc. up to that end in the normal order. So that winds up this portion of a 8-point F15 numerical. We'll see the later topics in the next video.